So in this video, we're going to talk a little bit about multiplication as our binary operation and what we have and don't have in that setting. So first, I'm going to go over this definition. We're going to translate it into a multiplicative definition. So S would be a group under multiplication. So S is any set, and it would be a group under multiplication if we had certain properties. So first we have this S is closed under, and I'm going to use a little dot for multiplication. And what we mean by that is that if A and B are in S, then A times B is in S. Okay, so that's our closed under multiplication. That's our binary operation bit of the definition of group. Associative in this setting would be for every A, B, and C in S, we would need that A times B times C is equal to A times B times C. So that's the associative property of multiplication. Part 2, the identity. So you should have thought through some of this in the previous quiz questions. For the multiplicative identity, what we usually call it is just 1. So there's a 1 in S such that for every A in S, A times 1 is equal to 1 times A, which is A. So our multiplicative identity is 1, the additive identity is 0. All right, and then part 3 was inverses. So for every A in S, there's supposed to be a B in S so that A times B gives us the identity, which is 1. All right, and now this is the one that's a problem very often. So this is often a problem. And so let's look at some places where that problem shows up. So, for example, and this is really a non-example, if our set is the integers under multiplication, so we're definitely associative, we're definitely closed. If I multiply two integers, I get an integer. There's a 1, that's an integer, and A times 1 is A for any integer. But 2 is an integer, and there is not an integer so that 2, let's see, there's not an integer B, so that 2 times B equals 1, because we know that that B would have to be a half, and that's not an integer. Okay, so then another non-example is, well, okay, so what if we allow Q, allow rational numbers? And so then we have, like before, if I multiply two rationals, I get a rational. I can do the associative property of multiplication, that's fine. 1 is a rational number, that's fine. But this time, we'll have inverses for everything almost. So any rational number A over B has a multiplicative inverse, which is B over A. We know that. But 0 is definitely a rational number. But like before, there does not exist a rational number B so that 0 times B is 1, the multiplicative identity. So we run into this problem all over the place with 0.